Hey, ninth graders, we're going to do our fishing adventures task. This is on page 57 of your math binder, and let me zoom out so you can see it just a little bit better. So our fishing adventures got some new boats. These boats can carry a maximum of 10 people and 1,500 pounds. Here's some other important information. An average child weighs 150 pounds. An average adult weighs 150 pounds. An average child weighs 75 pounds, and there is 300 pounds worth of fishing gear already on the boat. The extra gear on the boat means that no one has to bring any extra fishing gear with them. So you're going to come up with 3 possible groups that could safely ride in the boat, and you're going to be prepared to defend your examples. So your job right now is you are coming up with 3 separate groups of people who could ride in this and not sink the ship. Okay, so I don't know, like if you were to decide like one person and one person, well, if you were to say 1 adult and 1 child, what would that look like? Well, if you had 1 adult and 1 child, I'm just gonna write this on a separate piece of paper because I don't want you, well, you could steal this if you wanted to. 1 adult and 1 child would be 150 pounds for the adult because there's only 1 of them. And then it would be 75 pounds for the child because there's only 1 of them. But what else do we have to put on this boat? Fishing gear. Okay, so you have to add all that fishing gear and you wanna see if it fits within the parameters. So we have to add on the 300 pounds of fishing gear, and let's see what that equals. Grab my calculator. So we have 150 plus 75, and those are both multiplied by 1, plus 300 equals 525. Is that a safe amount of people? Yeah, totally safe. Okay, so there's an example done for you. I need you to come up with 2 more groups of people that could safely ride on this boat. Okay, keep going. Push pause. Okay, hopefully you came up with some really good examples. Let's see if, I'm gonna give you 3 random examples that have come up in years past, and some of them are weirder than others, but we're still gonna check them out. Okay, so one of the ones that people come up with is 150 pounds for 6 adults plus 75 pounds for 4 children plus 300 pounds of fishing gear. And when you add that up, 150 times 6 plus 75 times 4 plus 300, I get 1,500. That is exactly the amount, but I'm going to use a different symbol here. I'm going to say that that is less than or equal to 1,500. It totally works. Okay. But something that I didn't give on my other example was that's not the only thing you're trying to do. Yes, you are trying to stay under or equal to 1,500 pounds, but there was another piece of criteria that we had to follow. If you read your directions carefully, maximum of 10 people. So let's also check the 10 people allotment here. I've got 6 adults plus 4 children, and that equals 10. Yeah, so that would be less than or equal to 10. It follows that second criteria, and we follow the first criteria. So this group would survive on the boat, even though you're really pushing it with like being exactly 1,500 pounds, but you know what? Everybody has their own level of making their own choices. Okay, let's look at another example. Oh boy, I always see some people who do something like this. They say, let's see, 150 times like 5 adults plus 300 pounds, and they say we wouldn't want to take any kids. Yeah, that is maybe true. I probably wouldn't want to take a kid on a boat either. So if we did 150 times 5 adults, what are we doing with children then? Well, we're doing 75 pounds for 0 children plus 300 pounds of gear, and that is less than or equal to 1,500. It works because remember it was 1,050. And then if we add those together, 5, do that in pink, 5 plus 0 is less than or equal to the 10-person maximum. So a group of 5 adults would be safe. I always get someone who thinks they're pretty clever coming up with this next one. They say, well, we could do 0 adults. I don't like where this is going. Plus 16 children on a boat. Plus 300 pounds of gear. And let's see what we get. 75 pounds times 16 children plus 350 pounds of gear is exactly, oh, I don't know why I put 350 pounds of gear. Is exactly 1,500. So yes, it's less than or equal to 1,500 pounds. That would be the worst thing in the world. But tell me why it doesn't work. When we do add up, is it less than or equal to 10? No. So thank goodness it is not legal to have 16 children on a boat for fishing adventures. All right, so let's look at this next part. Part B, we're gonna write 2 inequalities to illustrate all of the constraints of this problem. Don't forget to assign X and Y. So I'm gonna start by saying that X, well, I'm gonna make X the first blank that I was always filling in, and I'm gonna make Y the second blank. X was always the number of adults, Y was always going to be the number of children. So I will say X equals number of adults, and Y equals the number of children. Okay, so when I write my equation, we always had 150 times the adults. So I will say 150 X plus 75 pounds times the children, Y, plus 300 pounds, and that's got to be less than or equal to 1,500. My second inequality, though, was always just add up the adults plus the children. So add up the X plus Y, and we want that to be less than or equal to 10. Okay, so our job now, part C, is to graph them on the same coordinate plane to find solutions. So if I've got this graph here, I'm going to get both of these equations, inequalities, and I want to solve them so I can actually graph them. So I already said that X was the number of adults. Down here, I'm going to write number of adults. It's a weird way to say it. Over here, I'm going to say Y is our number of children. Okay, so when I go to graph this first inequality, I need to write it down, 150X plus 75Y plus 300 is less than or equal to 1,500. And I'm gonna start solving this thing for Y so that I can graph it. I can begin by subtracting 300 from both sides of this inequality. Those will be gone, and I will have 150X plus 75Y is less than or equal to 1,200. Next thing that I want to get rid of is that X. So I'm going to subtract 150X from the left side, and I will also subtract 150X from the right side. Now I'll still have 75X, and I'll still have less than or equal to, but remember, I always want to put the X piece in front. So negative 150X plus 1,200. Last step, I need to undo multiplying by 75. So divide by 75, divide by 75, divide by 75. Are you seeing an error with what I did there? That was not 75X, that was 75Y. I hope that nobody panicked when I did that or came up and asked me questions, which that's great if you did. Okay, when we divide this, let's see. Negative 150 divided by 75, I get 2, negative 2, and 1,200 divided by 75, I get 16. So my final answer will be Y, and then I don't flip the symbol because I didn't divide by a negative anywhere. Because that 75 was positive and I divided that everywhere. It doesn't matter if the 150 was negative, it's just what you're dividing by. Okay, so that is less than or equal still, because again, I don't flip the symbol, negative 2X plus 16. There's my first inequality. before I even touch the second inequality, I'm going to graph and shade the first inequality. So let's graph and shade this thing. I'm going to start with my first dot at 16. My slope says go down 2 to the right 1. So down 2 to the right 1, 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 and down 2 to the right 1. All right, let's connect those dots. Before you connect them, is it solid or dashed? Well, we've got an equal to, so this is going to be solid. And remember, because this is talking about the number of people, we won't draw arrows because you cannot go infinitely into the negatives. Okay, I'm gonna use a test point. I'm going to use 0, 0 as my test point. So I'll draw a little star over here. And when I test 0, 0, I'm plugging it into the original equation. So 150 times 0 plus 75 times 0 plus 300 is less than or equal to 1,500. So all of this stuff is 0. Is 300 less than 1,500? Yes. So I'm going to shade everything below this line. Beautiful. Okay, let's go to the next part. The next part, I need to do the x plus y is less than or equal to 10. So down here, x plus y is less than or equal to 10. I can subtract x from both sides of this inequality, and I've got y is less than or equal to negative x plus 10. When I graph that, I start at 10. That negative x is down 1 to the right 1. So I go down 1 to the right 1, 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 down 1 to the right 1. Okay, solid or dashed? This has a solid equal to on it, so I'm going to connect it with a solid line. Okay, then I'm going to use my test point. I'm going to use blue. So I'm going to test 0, 0 again. Is 0 plus 0 less than or equal to 10? Yeah, 0 is less than or equal to 10. So here's where you have to be really nitpicky. That last one shaded everything below the first line. Now I'm shading everything below the second line. What you're going to notice now, I have a pink region, I have a white region, I have a blue region that's not pink down here, and then I have a blue-pink region, which would be like a purple region. So here's what's really cool. The double shaded region is your solution. Every solution that works here is in the double shaded region. Our coordinate, which was 6 adults, 4 kids, well, 6 adults, 4 kids, it worked. Our solution of nobody, 0 adults, 0 kids, yeah, it worked. It was in the double shaded region. 1 adult, 1 kid, it worked. All of these down here are our solutions. If you go up here, it's gonna break one of the solutions and work for one. If you go down here, this blue section will fit one of the solutions, but not the other. So let's keep all that in mind, because now we are taking this and we are making double equations, and we're gonna be looking for that double shaded region. All right, let me know if you have any questions. Good luck, ninth graders.